Hello, welcome to Revision Screencast. So the focus on this one is going to be looking at anaerobic pathway, linking anaerobic energy systems to strength training. Now, just to make this very clear, this series of screencasts is focused on potential synoptic links, so for regard for a 20-mark question, but within that I'll be looking at the fact that these areas are massively under-examined at A level. Energy systems, zero coverage last year; strength training, zero coverage last year. So it's really important that we have an idea of these, both for a potential 20-mark question, but also for kind of 4, 5, 6-mark questions within the paper. So if we have a look then, this is how we're going to be looking across the specification. Your 20-mark question has to come from 2 out of the 3 columns. So column 1 linked to column 2, column 3, column linked to 2, whatever. Okay, that is what you're looking for this. So particularly in this screencast, we're looking at energy systems linked to strength, and we're looking at anaerobic process. A little bit more detail if you have a look at this point here. So we're looking at this idea of anaerobic physiology. We're going to be looking at 2 specific energy systems. So look at ATP PC and glycolytic. We're going to have a look at how they link to a particular type of strength, e.g. muscular strength, and then we're going to have a look at kind of the adaptations from that. We're not going to cover ergogenic aids, but I'm sure you could do that as a little revision task to make sure you have an understanding. If you're trying to improve strength, pharmacological, physiological, nutritional aids that could increase muscular strength or anaerobic performance, I suppose. Okay, so if you have a look then, potential questions you could get. First one, using examples, critically evaluate the use of anaerobic energy systems in a football game, in a netball game, in a basketball game. When doing this, I use football game. I think netball could be a really good one with regard to kind of linking it to part 2. So what I've put here is part 2, devise a 6-week training program to improve explosive strength, and then explain how the program would improve health or fitness. Now, that was an old spec question. What that means is linking it to it would be fitness in the new spec, which would mean adaptations. The other part 2, so bearing in mind we're allowing to the strength training, could be just specifically asking you to devise a plyometrics training program to improve explosive strength and evaluate its use as a training method. Then it might ask you to explain the physiological adaptations after a period of plyometrics. So this is the way it could be set up. Part 1 coming from kind of part 1 of the specification, part 2 coming from the second component within training. So that is the type of thing you could get. The difference between these we'll have a look at later is the fact that this one asks about explosive strength training program, therefore we have to talk about weight training and plyometrics, whereas this one is just asking about plyometrics as a training program on its own. Okay, let's have a look then. ATP PC system, I'm going to give a very quick overview of this then. If I asked you on here, maybe using the kind of section here, how do you feel with regard to the fact or what ATP is, how it's broke down, and then how PC is used in a coupled reaction to resynthesized ATP. So I'll leave that on there. If you want to have a go at doing that, that's fine. Pause it now. If not, if you want to have a look at this, if you're struggling, just to give you an overview with regard to what is happening here, that's absolutely fine. And of course, I've put down here YouTube links. Will link to all of these. It'll explain it in full detail. So if you have a look onto here, then what we'll be looking for the ATP PC system, you'll be looking for the following. So you're looking for ATP broken down by. I'll put this list up here. So ATP broken down by ATPase there to form ADP plus P plus E. Okay, and then the E. Is an exothermic reaction here, but that is just used to give us our 3 seconds of work. Then we have this idea of, because we've kind of lost ATP, it's been broken down to ADP plus P plus E, we then need to use phosphocreatine and break down PC in order to create a coupled reaction to resynthesize ATP. So PC, creatine kinase to leave P plus C plus E, and then from that point on, the E is an exothermic reaction. So we're looking here, the energy is then used in a coupled reaction to join the P to ADP to form ATP, which is an endothermic reaction, which will lead to kind of resynthesis of ATP up here. Okay, so you can see that in action. So P, C, creatine kinase, P plus C plus E, E plus P plus ADP equals ATP. That's the coupled reaction, and it's really important. I suppose I'm going to give you a couple of points just to consider now. Within an exam question, if this is a 20-mark question, which is the overview that I'm looking at, you put this into kind of a process. So if it's a 20-mark question, you just started off by talking about the role of ATP. What is it? Where do you find it? Why is it so important? Then you would talk about the kind of ATP breakdown, how it's broken down to give us our 2 to 3 seconds of energy. Then we talk about PC as a fuel that is broken down in a coupled reaction to resynthesize ATP. So I haven't put everything on here, so just to make sure you know, if it's a 20-mark question and it's linked to ATP, you start off with a paragraph based around ATP. Now, if I move on from there, then these are the separate questions you must be ready for with regard to kind of ATP PC system. So you could get a separate question asking you to explain the principle of an energetically coupled reaction. This is an old spec question. If that happens, it's really important. You know the different, you know how to do that. So if we put it onto here, I mean the description of a coupled reaction here, linked reactions taking place, product of what. I want you to make sure you use energy from reaction 1 is used in reaction 2, and then you do the process of PC breakdown as an exothermic reaction, P plus C plus E, and then you look at the E plus P plus ADP as an endothermic reaction, and you must make sure you give examples to show you understand 1, the breakdown of PC in coupled reaction 1, 2, the resynthesis of ATP using the E plus P plus ADP in reaction 2. So that's one question you get. Another thing I just wanted to draw your attention to, if you get a shorter question, is this idea here. And I'm only going to, you look at it, using examples from sport, explain or describe how players resynthesize ATP during a game using the ATP PC system. Now, obviously, it's lactic acid, old spec question. Really interesting point here, just to make sure you don't overwrite, is when you're talking about a question, if it's a short question that asks about the ATP PC system, you're talking about PC in a short question, because ATP, we're not talking about that. So if you have a look on here now, when you're talking about this, you have to give an example. Yes, so for example, a powerful shot on goal, a tackle in rugby, or whatever. Tackle in rugby, because it's a team sport of your choice. Key thing is it talks about PC, how it's broken down. Okay, the enzyme that's used, maybe the coupled reaction that gets ATP. What it doesn't talk about is the original breakdown of ATP. Okay, so just keep in your mind, if a question asks you to give a sporting example and describe how ATP is produced in the ATP PC system, your job is to talk about the breakdown of PC in this type of question. Okay, so I just want to give you those two specific little questions you could get. Now, when we are evaluating the ATP PC system, it's really important that we use the framework in order to allow us to evaluate. So I've got fatty BC here. When you do that, just remember that stands for fuel, aerobic, anaerobic, time, energy yield, byproducts, complexity, site, sporting example. Now, just making sure that you can, firstly, this framework allows you to summarize. So you've got that there. Now, once you've got the summary of it, this will form the basis of an evaluation platform. So now, if it's a 20-mark question, this is going to be the kind of stuff you're going to need to be able to do. So, of course, the key evaluation point here is I'm going to look at the idea that PC is readily available in the muscle, and it can be resynthesized quickly. So it's readily available in muscle. It could be resynthesized quickly. We know from the kind of fast epoch that 50% can be recovered in 30 seconds, 100% in 3 minutes. However, PC stores run out quickly. I'll let you have a read of that. They're the kind of evaluation points. That's how you use the framework in order to start to summarize, but then to kind of provoke an evaluative context to give advantages and disadvantages there. Reds, disadvantages, greens, advantages. So if we move on. Glycolytic system then. Excuse me. So glycolytic system, when you're looking at this, what we have to do, if you want to pause it now and have a go, is we have to talk about the idea glycolytic, glycogen. From glycogen, we need to know the enzyme that breaks it down, what is formed as a result, enzyme formed, and then down into here. Now, what I just want to make very clear on here, I'll let you pause it now, see how you feel with regard to answering that. Okay, so answer them. If we look onto here, you've got, at this point, I don't think it's really that much worth me going through the actual process of it. You can read, you'll have heard this, so just make sure you've kind of revised and put this in. So you've got this stuff down to here. Now, what is really important here, from glycogen down to pyruvic acid, is the process by which we get energy. If you got an exam question that asked you about the glycolytic system and how it produces energy for kind of sporting events, you could go down to glycogen, glucose, pyruvic acid with the correct enzymes, of course, 2-ATP, and you would get away with going to lactic acid. What you would not need is to go into the negative effects of lactic acid if a question asked you about how the glycolytic system provided energy for sporting events. If a question had a subsection that said explain why, the glycolytic system cannot go past a certain period of time, and then you talk about the disadvantages of lactic acid and the problems behind it. The acid going up in the blood, decreasing pH, denaturing enzymes, and then this lead into this idea of kind of obla being accumulated fatigue, intensity and duration having to slow down. Okay, so that would be an example there. So let's have a look what I mean by that. So this question came up. It's a specimen. It's a really good question actually, and caused problems. So I looked here. So looking at elite swimmers could complete 100-meter freestyle under 1 minute. Now, this asks you to describe the predominant energy system used by elite swimmers during 100 meters. Now, from this point then, this is a 5-mark question, the predominant energy system. Identify it and put it into context and how it gets the energy. But if you did too much and didn't read part 2, this asks you to explain why the use of this energy system cannot be sustained for more than several minutes. That was the negative impact of lactic acid. So if you see here, part 1, it's talking about the right system, glycolytic system, and the process of which you use it. Make sure you've got 5 from there, 1 and then another 4. And then from that, this was the second part, which asks you to talk about the idea of lactic acid and the negative effects of it. Okay, so you're talking about acidity, pH, enzyme inhibition, and stuff like that. So that would be the kind of stuff you're looking at there. Now, if we move on, how do we evaluate the kind of anaerobic system 2, so the glycolytic system? So when you're talking about this, then of course you use the same process. Our summary framework, so that's our summary there, so hopefully you feel okay with that, and then we have a look at this idea of the framework to evaluate, and again, same process here. So I'll let you pause that if you want to have a look at those kind of key bits on here. These are the examples of how you will give evaluations in there: fatty BC, plus plus, minus plus, minus plus, and this gives you a good kind of process behind how you evaluate the system for anaerobic or for glycolysis or the glycolytic system. Okay, right, let's have a look then. That's part 1. Let's have a look at how this could link to strength training. Now, if you got this question and it was linked to the following, and we looked at this earlier, let's have a look at example of if it was the question 1 here, so devise a 6-week training program to improve explosive strength, we would have to try and incorporate weight training and plyometrics. So firstly, we have this kind of idea of weight training. Okay, so 2 types of weight training: multi-gym, exercise machines, adjustable weight stacks. You can read that. And then on here, freestanding weights that require a spotter. They're your 2 types. Now, what is absolutely vital for this exam is, 1, we have an understanding of the training types of weight training. Secondly, we understand if the question asks us about a certain type of strength, we know which one we know how to kind of devise the parameters that are going to allow us to improve that strength. So these are huge for this exam. For this particular question, it asked about explosive, so you go across the middle here and make sure that you can have an understanding of that. So you've got your reps here for always the same, 3 to 6 sets, and then from that we just look at we build at 1 to 5 for max strength, because that's the one we need to lift the most weight, therefore the lowest reps, and then it slowly builds up to explosive, 5 to 10, 10 to 20. Explosive for this one, what we're looking at, 75 to 85%, 1 to 3 work rest ratio, 4 to 5 minutes rest. Please learn these because they are really likely for this exam. So that is kind of what we're looking at with regard. Explosive was the angle we were looking at for a 20-mark question, but it could be maximum, of course, it could be strength endurance, and make sure you've learned them all. Now, plyometrics then. Really important kind of strength training for this exam, so making sure we have an understanding. It is a series of explosive actions, and the idea, the physiology behind it, an eccentric contraction followed by a concentric contraction, initiating a stretch reflex, which will lead to explosive force. Now, as you get from here, we've got this idea of this is how it works. Now, you must learn the fact that the intensity here, I mean, really, 3 to 6 sets, it should be somewhere like 1 to 5 reps, 1 to 6 reps, really, but a maximum of 10 reps when you're doing plyometrics because of the explosive nature of it. Now, the key difference to this than any other strength training is the intensity. It's high intensity, but of course, because it's plyometrics, there are no weight-based parameters. There are no percentage of the 1 rep max. So your high intensity explosive actions with minimal time on the floor or minimal contact on the floor. So you explode up from the surface. It could be a box, and you're looking at 50 to 200 contacts. These are the key things you must make sure you've got in. And of course, if it asks you to discuss the use of plyometrics or evaluate it as a training method, you must make sure you've got an idea on how you could evaluate it. Okay, so they're the kind of evaluation points there. Now, I'll put in here the plan of attack. If a question asks you to do that, this would be the kind of process you'd be looking to go through. So pause this when you're ready, just to have a look at how you would do it. And yeah, so plyometrics one on its own would look a little bit more like this, and I will stop it at that point there.